So today we are talking about the prevalence of fiber optics in communication systems.
We will also discuss some of the properties of light and how a fiber optic cable works.
We'll also be discussing the applications that fiber optics have in communication systems.
Okay, so here we have a demonstration of total internal reflection. As you can see, as the laser light moves through this fluid, which is of a higher index of refraction in the air, and it hits the air-fluid interface, it then reflects back down at an angle that is same as the incident angle of the light. Okay, so here we have a diagram of a typical fiber optic cable, also sometimes called a light pipe, in which there's a cladding and a core layer. The cladding layer is of a lower index of refraction than the core layer. So what happens is the light enters in to the core of a fiber optic cable, and as it reaches the cladding core interface, it internally reflects, and then it keeps bouncing all the way down the core of the fiber. Okay, so the core of a fiber optic cable has an index refraction typically of 1.64, while the cladding has a lower index refraction of 1.52. And in the higher index refraction, the light travels slower than in the lower index of refraction. So as it meets the interface, it wants to bend back towards the slower medium, and that's how you get internal reflection. Okay. So here we are looking at the end of a fiber optic cable through a scope, and here in the center you can see the core of this fiber optic strand, and then this is the cladding around the outside, and then this is a protective plastic coating that carries the actual fiber strand. So this black part's the cladding, and the inner faint white part is the core. So here we have a laser that's shooting light through this fiber optic cable, and you can see it's going in on this side and it's coming out this end at the tip, and so it's bouncing around, internally reflecting. And you can kind of see too this internal reflection thing happening, and if you change the angle you get the critical angle, and it actually doesn't internally reflect and actually refracts out, and you can see it coming out the side if you bend the fiber too much, and the light actually comes out instead of internally reflecting. Okay, so here in Champaign-Urbana we actually work on a fiber to the home project that provides internet to the home through fiber optic cables. So basically this is a simple mock-up of how it works. Somewhere upstream there is a device similar to this that acts as a router for an internet router for the whole fiber to the home network. That feeds a fiber then to this device that sits in the cabinet in the neighborhood that it's serving, and it's called a fiber distribution hub. So it feeds a high-speed fiber optic cable to one of these cards, and then there's several of these cards, but we just have one here in the bottom, and that has a fiber optic port that then feeds out to the home on a fiber optic cable, and then connects to a device similar to this that then takes the fiber optic connection and converts it into a copper Ethernet connection that you can then plug into your computer or into another wireless router or something. And that's pretty much how you get fiber internet to the home. Okay, so here we have a fiber optic cable that we use for the UC2B Fiber Internet to the Home project. This cable here has 144 strands of fiber optic strands, and so that can feed 144 homes, and and it's in ribbons of 12 strands each, and that makes it easier to splice cables together. And so one of these strands that they have right here, I don't know how well you can see that, is about 50 microns across, so it's about the thickness of a human hair, but that's with the protective plastic coating around the outside. The actual fiber optic strand inside is only about 10 microns across, so about 1/5 the width of a human hair, and that can carry enormous amounts of data at very high speeds to the home. So that has been your brief introduction to fiber optic properties and properties of light in terms of internal reflection, and how fiber optics are used in communication systems currently in our society.